Solving 1 and 2 step equations. At the end of this lesson, you should be able to answer the question, how do I solve equations with variables on one side of the equal sign? Some of the big ideas to remember when solving all algebraic equations is that your goal is to isolate the variable, which means get it alone on one side of the equal sign with all your other numbers on the opposite side. Inverse operations will undo each other. So if you are trying to get rid of a plus 5 stuck to an x, to get rid of it, you would do the inverse, which would be minus 5. And finally, the idea of balance. Whatever you do to one side of an equation, you must do to the other. And there are 4 properties of equality that give you the authority to do this. So if you choose to add 6 on one side of an equation, the addition property of equality says you must add it on the opposite side. So I will refer to these 4 properties of equality throughout this lesson. Let's quickly remind you of one-step equations, which you probably solved in your pre-algebra course. These should all look pretty simple to you. Your goal is to get x on one side of the equal sign. So your 2 sides of your equation are separated by this equal sign. So if you're trying to get rid of this minus 5, you do the inverse operation, and the addition property of equality says you must do it to both sides. So negative 5 plus 5 is 0. Bring down the x, keep your equal sign in the middle, and negative 15 plus 5 is negative 10. Easy enough. In number 2, your goal is to isolate the y. So you need to get rid of this minus 3. The inverse of minus 3 is plus 3. So we do it on both sides to maintain balance. This cancels, bring down the positive y, and 11 plus 3 is 14. In 3 and 4, well, in 3, your variable is on the right side. That's fine, just keep it on the right. And separate my 2 sides. I'm going to get that a by itself on the right side. 4a means 4 times a, so the inverse of multiplication would be division. So we show that with a fraction bar. If I divide on the right, the division property of equality says I must do it on the left. 4 divided by 4 is 1a. Best written is just a. Equal sign in the middle, and negative 24 divided by 4 is negative 6. In number 4, I have b, or negative b over 3 equals 9. You could also think of this as b over negative 3. So that would help you get rid of the negative 3 in one step. It's held by division, so the inverse is multiplication. So I'm going to multiply both sides by negative 3. If you put this over 1, then you'll see that your negative 3 is reduced to positive 1, b is on the left, and 9 times negative 3 is negative 27. Number 5 illustrates when you have a fraction. That fraction is held by multiplication, so the instinct is that kids often want to put divide by 2/7. Well, that's technically correct. What that creates over on this side is a complex fraction. So there is a better way to show this. Rather than dividing both sides by 2/7, what's equivalent is multiplying both sides by the reciprocal. The reciprocal would be 7 over 2. It just kind of does a backflip is one way of thinking of that. 7 over 2. So on the left, they reduce to 1, x, which is just best written as just x. On the right, the 2 and the 22 will reduce, or you could let your calculator handle the fraction. So I will have 11 times 7 is 77, and there's a negative times a positive is negative 77. Finally, in 6, just to illustrate when you have the variable on the right, it's fine, just keep it on the right. I have negative 17 plus 4 would be negative 13 equals m. All right, let's go on to 2-step equations, getting more into Algebra 1 content. Your goal is still to isolate the variable. I think about what has been done to the variable, usually by the order of operations. Since I'm trying to undo it, in a sense, I'm working backwards. So whatever was done last to the variable, I will undo that first. And then I'm going to show you how to check your work using the substitution property. I don't do this always on every single problem, but when the problems get more difficult, it's a good trick to know. All right, so under example 1, I'm going to separate my 2 sides. And I think about what has been done to this variable, and I'm going to work backwards to undo it. So first, looks like it was multiplied by 5 according to the order of operations, and then 4 is added to it. So I'm going to undo these in the opposite order. So I got to get rid of the plus 4. So I do the inverse, I subtract 4. That gives me 5x equals negative 43. And then I'm going to divide each side by 5 to undo the times 5. The 5's cancel, become 1x equals, now negative 43 over 5, I'm just going to leave that in its fraction form. It doesn't reduce. I'm not going to change it to a decimal. In Algebra 1, we typically leave things in their fraction form. Now, I'm going to do my algebraic check just to show you how to do one before we go any further. An algebraic check says take my original equation and plug in what I think the answer is in place of the variable. And I evaluate. I check, does the left side equal the right side? So if I plug in, let's see, I think it's negative 43 over 5. And you can just plug the left side into your calculator. The 5's would cancel, and I get negative 43 plus 4 is negative 39. Since my left side equals the right side, I know that I didn't make any errors. Okay, so let's do example 2. P over 4 minus 3. So by order of operations, it would have been divided by 4, and then 3 is subtracted from it. So I'm going to undo things in the opposite order. So I need to get rid of the minus 3, which means I add 3 to both sides of my equation. This cancels. Bring down the P over 4 equals 8. Now, undid the minus 3, I just have to undo the divide by 4, which means I multiply both sides by 4. So notice I put the 4 like it's up in the numerator. Sometimes if you put 4 over 1, it's easy to see then that your 4's cancel. And I'm left with P equals 32. Okay, so if we would do an algebraic check for this one, if I plug in 32 everywhere I think there's a, or everywhere there's a P, so 32 over 4 minus 3, does that equal 5? So 32 divided by 4 would be 8 minus 3 is 5. Since I get 5 on both sides, I know I did the problem correctly. Okay, in number 3, my goal is to isolate the variable, get two sides to my equation. This time, looks like it was multiplied by negative 5, 6 first, and then 8 subtracted. So I'm going to get rid of the minus 8 by adding 8. 7 plus 8 would be 15 equals negative 5, 6b. Now, the negative 5, 6 is held by multiplication, so the inverse would be multiplication, or I'm sorry, the inverse would be division. But again, that's going to give me a big, ugly fraction, so I'm going to do that trick of multiplying by the reciprocal. The reciprocal does a backflip, it's negative 6/5. Sometimes kids say, well, doesn't it have to be 6 over negative 5? Always keep your negative sign up in the numerator. In Algebra 1, it's best written that way. So my 6's cancel and my 5's cancel, and a negative times a negative is a positive b equals, over on the right, put the 15 over 1, and the 5 and the 15 will reduce. This becomes a 3, and negative 6 times 3 is negative 18 equals b. Okay. You can verify that with an algebraic check. I'm going to move on to example 4. In number 4, common error here is that kids will try to add 3 to both sides. But you want to get rid of this 3 first. Since that's a positive 3, we're going to subtract 3 from each side. 3 minus 3 is 0. So what remains is a negative y equals 14. If you think about negative y, what coefficient is understood to be in front of that y? It's a negative 1. So to get rid of it, it's held by multiplication, we're going to divide each side by negative 1. So I get y equals negative 14 as my final answer. Example 5 is just a little bit different because of the big fraction bar. So if I look at this, x minus 3 all over 4, that means 3 was subtracted first and then it was divided by 4. So I have to undo my division first. So I'm going to do the inverse, which is multiplication. I'm going to multiply both sides by 4. So if I put this over 1, you can see it's up in the numerator. The 4's cancel, and I'm left with just x minus 3 over 1, which is x minus 3 equals 24. And then, one more step, I add 3, which gives me x equals 27. To do a check, just to make sure, plug in 27 minus 3 all over 4. Does that equal 6? So 27 minus 3 would be 24 divided by 4 is 6, so I know I'm correct, and I did things in the correct order. All right, the last one is an example of going through the steps of writing an algebraic equation and then solving it. Julia is saving her money to see Newsies on Broadway. She earns $8 per hour babysitting the neighbor kids, and her grandfather gave her $35 towards her trip. If she needs $155 for her trip to New York, how many hours must she babysit to have the money she needs? Okay, so I reread the question mark sentence. How many hours must she babysit to have the money she needs? How many hours is what I'm looking for. So the first thing I do is I create a variable and I call it h. I'm going to say that's my number of hours. If she earns $8 per hour, the best way to show that would be 8h. 8 times h to get how much money she would get. If she worked 5 hours, it would be 8 times 5. So I represent that as 8h. Plus her grandfather gave her some, so that's going to increase her amount by 35. And she needs that to equal $155. So here's the algebraic equation, which kids typically find the most difficult setting it up. They can often get the answer, but writing the equation is more challenging. So as easy as it would be to skip this step right here, don't do it. It will help you in the long run to practice it. So let's solve it. We're going to subtract 35 from each side. So 155 minus 35 is 120. So I have 8h on the left. I'm going to divide each side by 8. And 120 divided by 8 is 15. So she must work 15 hours to have enough money for the trip.